During this lesson we should be using VirtualBox and 3 guests running Windows XP, 8 and 7. Let's first check the IP address of each of the hosts. To do this we shall use the command ipconfig. With the first guest running Windows XP, we can see that there is an IP address of 10.02.15 and the subnet mask is 255.255.255.0. The default gateway is 10.0.22. Now we run the same command on the guest running Windows 8. And this displays an IP address of 10.0.2.15 and a subnet mask of 255.255.255.0. The default gateway is 10.0.22. Finally, the guest running Windows 7. Its IP is 10.0.2.15 and the subnet mask is 255.255.255.0. The default gateway is 10.0.22. Let's create a model and enter the information we have just found. The first thing you will notice is that the IP addresses are all the same. So are the subnet masks and the default gateway. Another peculiar thing is the subnet mask. It is 255.255.255.0, which implies that the IP address is a Class C, although the IP address is actually a Class A, since it falls within the range of 0000 to 127.255.255.255, which should have a subnet mask of 255.000. This is because of VirtualBox and how it is initially configured. It is using NAT, or Network Address Translation. This is the process of one IP address communicating with another on a different network via the default gateway. This is explained more in depth in the advanced diploma. In the following task we need to change this to an internal network interface, so close all the windows now. Select one of the guests that we'll be using during the task, then click on Settings within VirtualBox. Select the network, then click on the selector to the right of Attach To. Change this from NAT to Internal Network. Just so we can be clear, this adapter is part of the virtual guest and does not really exist. As far as we are currently concerned, it's as though we have just installed a network card into this guest. Click on Advanced and check that the cable is selected. Also at this point, notice the MAC address or Media Access Control address. This is a unique number that is allocated to just this adapter. And this is also true in the real world. No two network adapters can have the same MAC number. Once again, there is a full explanation within the advanced diploma. Click on OK. Select the next guest. Settings, Network. Click on the selector to the right of Attach To and change this to Internal Network. Click on Advanced and check that the cable connection option has been selected. Once again, notice the MAC number is different again. Click on OK, then select the final guest. Settings, Network, and select the Internal Network. Advance and check that the cable connected option has been selected, then OK. Start the first guest. Once again at the command prompt, check the IP address. So this guest has now returned an IP address of 169.254.119.30 and has a Class B subnet mask. Notice there is no longer a default gateway. Let's check the second guest. This time the IP address is 169.254.64.29, and again is a Class B IP address with a subnet mask of 255.255.00. Then the final guessed IP address is 169.254.86.173 with a subnet mask of 255.255.00. Let's return to our model using the data that we have just collected, so we can examine the IP addresses. The first guest had an IP address of 169.254.119.30 and a subnet mask of 255.255.00. Once again, there was no default gateway address in any of our guests. The second guest had an IP address of 169.254.64.29, also with a subnet mask of 255.255.00. And the final guest gave us an IP address of 169.254.86.173 with a subnet mask of 255.255.00. Let's complete the model with a central unit and connect them all together. If we examine the IP addresses, we shall find them all on the same network ID of 169.254.00, so technically they should all be able to communicate. We shall return to our guest to see if this is true. In our example, we will try and ping the Windows 8 from the Windows XP guest. So we enter ping 169.254.64.29. Look at the message, it tells us that this recipient cannot be found. Let's try this again from the Windows 7 guest to the Windows 8. Once again, the same result, request timed out. This is where a network administrator's job starts, being able to track down problems in a logical manner. In this part of the BTEC, we'll only be looking at the basic network problems. We discover how to solve more complicated problems when we move on to the level 3. For now, we know that the network ID of all the guests are correct, so they should be able to communicate. But there is a security setting that was introduced as early back as Windows XP called the firewall, and this controls sharing. It is the setting that requires altering. On the guest running Windows 8, right-click on the network icon found on the desktop and click on Open Network and Sharing Center. Click on Change Advanced Sharing Settings, and here we have three options. The one we shall be altering is the guest or public, so click on this. Select the Turn on Network Discovery option and turn on File and Printer Sharing, then click on Save Changes. Now return to the Windows XP guest. We could just type out the ping command again, but we can also use the up directional key, just the once to repeat the last command. If we want to repeat the command before this, then we would press the up directional key twice, etc. Now press the Enter key. This should have received a reply from the Windows 8 guest. Let's return to the Windows 7 and repeat this by pressing the up directional key just the once. We should also receive a response. Now let's return to the Windows 8 and try and ping the Windows XP guest. We received the message, Request timed out. Let's try this again, but ping the Windows 7 host. We shall use the up directional key to repeat the ping command, then using the backspace key, type in the Windows 7 IP address. Bear in mind that the IP address shown here, 169.254.54.29, is this host IP address, and it is telling us that the destination host is unreachable. Once again, it has failed, so we seem to have communication in one direction but not the other. Let's return to our model. Initially we could not communicate in any direction, then we used the File and Printer Sharing option on the Windows 8 computer. Now we can communicate between Windows XP and Windows 8 and the Windows 7 and 8, but not in the other direction. This is because the other guest sharing options should also be altered to allow sharing. Let's repeat the File and Printer Sharing on the other two guests. On the Windows 7, right-click on the network icon found on the taskbar. Click on Open Network and Sharing Center. Click on Change Advanced Sharing Settings, then on Public. Select Turn on Network Discovery. Turn on File and Privacy Sharing. Then turn off Password Protection Sharing. Click on Save Changes. Now return to the Windows 8 guest and try and ping back to the Windows 7 by using the up direction key just once. We can now see that communication has taken place between these two hosts. To set the Windows XP, click on Start, Control Panel, Windows Firewall. Click on the Exception tab, then select File and Printer, then OK. We can check for connectivity between the Windows XP and Windows 7. So here is proof that if all the guests are on the same network ID, they should be able to communicate providing the file and printer sharing are also enabled. The question that lies here is, where did these IP addresses come from?